Okay. Just going to give it a couple minutes for everyone to join in. And then we will get started. So, because I think I'm supposed to start at 1, we'll let it go till 1. And if you are listening and you have any questions along the way, feel free to throw them in the chat. I'm going to try my best to watch the chat as we go forward and make sure we answer those questions. It's not going to be easy because I have like 3 screens going on, but I'll try my best. Also hope everyone can hear me okay. But again, just trying to kill a little time before we actually have the official start time, which is about 30 seconds away. So I will mute my phone and then we'll get started. As I see a couple more people join. Welcome everyone. My name is Brian McKeever. I am co-owner at Bizstream, and I'll get into that in a second. But today's session is part of Global Azure 2022, and I'm going to talk about high availability with Azure Paths for websites, because that's primarily what my background in is, what I do at my company. So we're going to get into a couple options of how to do that. I'm going to focus on mainly Azure App Services, because that's probably the most common option. But I'm going to talk about a couple cool new things that you may not know about, and then really kind of get into my goal of just educating everyone on what does it take to accomplish high availability. Because a lot of people spin up apps and sites inside of Azure, but they don't really always take it to that next level, and that's something I think that should be more common as we deliver websites that need to be worked 24/7. So I'm going to get into that. And with that said, let's get started. So again, thank you to all the organizers for putting on the Global Azure Conference. I think it's a fantastic conference. This is my 2nd year speaking at it. It always impresses me how they get like hundreds of speakers around the globe to speak for these couple days. And I'm just happy to be a part of it. And I think it's a really cool thing. So with that in mind, let's get started. As I said, my name is Brian McKeever. I am co-owner at Bizstream. We are a digital agency in West Michigan in the United States. And my background is technical. I've been programming in .NET since it wasn't even .NET. It was actually classic ASP. So actually, funny enough, today is my 20-year anniversary at Bizstream. I've been doing it for a while. And along the way, I've done classic ASP, regular ASP.NET full framework, .NET Core, now .NET 5 and .NET 6. So basically been a .NET developer my whole life. And at Bizstream, we build websites for people around the country. So that means we need a place to host them, and we do that in Azure. And for my knowledge on the Azure platform and content management systems, I happen to have been recognized this year as a Microsoft Azure MVP because of my knowledge in how the tools and how you put these things together and how we help our clients do that. And for the last 10 or 12 years, I've actually been a Kentco MVP as well in both their experience product as well as their headless CMS product, because we build on top of their CMS offerings, because I think it's impossible to put together a good solution that your marketing team can't edit when it comes to building websites or e-commerce. And that's actually what we do at Bizstream, as you can see on the slide here. We are a long-term agency, been in business for 21 years, and we help clients across North America, even up into Canada and down into South America, build very complex digital properties for their brands, for their customers. We do portals for dealers, customer portals, native apps, pretty much the whole thing that you would imagine doing with any kind of major application that needs some integration. And more recently, we've actually kind of expanded into the full creative and digital space of digital marketing, branding, creative, all sorts of fun things that go on top of that. So we're really an agency that can almost do it all. And I'm really proud of that because we're about 30 people, and our building is actually surrounded in a cornfield in West Michigan, but yet we can make global reach almost. And it's a lot of fun. So That's all I'm going to talk about myself and Bizstream for this talk, because really we're here to talk about Azure. And I would hope at this point, if you're listening and part of the sort of Azure platform community, that you know what Azure is. So I'm not going to actually introduce it, but generally, I believe that Microsoft Azure is the best way to host a .NET based application, or even maybe not even a .NET based application these days. I just think it's a fantastic cloud offering. Even though historically I was actually a big fan of Amazon AWS and the way it worked, I think they're now very similar. And in the last 5 or 6 years, I've really slanted more towards the Azure offering. And I have the ability to compare and contrast some of the different resource types from, whether it's a EC2 instance, serverless with Lambdas, whatever, or, Azure Functions, Logic Apps, Azure App Services, virtual machines. And I have kind of a good experience in the cloud. And, I just believe that Azure is the leading choice these days. And I hope you do too. That's maybe why you're watching at the Azure conference. And I'm here today to talk about high availability. So if we talk about high availability, really that comes down to uptime. We want to deliver solutions that work 24/7, that don't slow down, that don't break, that don't have issues, that don't require troubleshooting, that, if you make a deployment, things don't stop working for 5 minutes because you have an e-commerce site that needs to take orders all the time, and 5 minutes can be super costly. In fact, as the slide shows here, according to Gartner, the average cost of an IT downtime is $5,600 per minute. I'm going to let that sink in a little bit. That's actually, I think it's like $300,000 an hour. And I was actually shocked at that statistic. I thought that was a huge number. But the more you think about it, when you have downtime and you get that support ticket that comes into your system, or that customer phone call that's like, why is my website not working? It's actually super frustrating, right? And you have to maybe get network people involved. You've got to get application developers people involved. Your support people are there. Maybe you've got customer service or account management team that would need to handle communication to clients. You start adding up all of the people that it takes to handle an outage or downtime. And then even once things are back and working, how you have to communicate, root cause analysis and all the other work that goes into it, that number actually kind of makes more sense. And it's not just my number, it's Gartner's number. They kind of know what they're doing. So really we're trying to avoid those outages. We're trying to save money, save frustration when we talk about adding high availability into our solutions, right? And I would think it makes sense to start maybe with what not to do when it comes to adding high availability into Azure Paths. And it's funny that the background of this slide, it makes me laugh. And if you were here in front of me with a crowd, I would say, all right, everyone raise their hands. Who's ever been in a room like this where you have an old kind of CRT monitor hanging out to a bunch of switches and server blades in a rack, and someone's trying to figure out, oh my gosh, why is their website down? Where do we need to look at? What do we need to terminal into? This is the old days. This is how we used to do it before there was the cloud. And really there's two reasons I bring this up. When we think about the old days, the on-premise infrastructure, your Windows server with IIS, and maybe it's connected to a network share for its file system and its images and PDFs, and it's all coming out of one office location that's maybe here in Michigan in the US, or maybe it's a Florida location or California, and it's slow for people around the globe. The way to not think about this is to say, I can use these old techniques and tactics of, I'm just going to pick up that full virtual machine, whether it's on-premise or wherever, and I'm going to take a virtual machine and I'm going to put it into the Azure cloud. Because yes, you can do that. You could stand up virtual machines, spin up a server, have to deal with the operating system installs and maintenance, have to do with updating the .NET framework or the .NET 6 components, worry about security, networking, firewalls, all those things. And I'm trying to say today, that is just not needed in all cases. There's still a couple edge cases where you might want to think about virtual machines or IaaS, infrastructure as a service, as a solution for website hosting. But most of the time, I don't think so. I think in most cases, you don't need to do this because it doesn't take the full advantage of the cloud and the way that you can do performance and scaling and go from just a pure compute center, which is what a server operating system is, like it handles the computing, but it can be an entire deployment solution with capabilities that are built into the Azure Paths way. So that's what I'm going to spend the rest of the talk talking about, is what other things add into Azure Paths that make it have these major benefits and advantages of this new way of doing things. And the second reason to not think about doing it the old way is really the idea of scaling and availability. In the past, maybe you would use like a software load balancer that's in this rack behind you, and you would try to split traffic between two servers with some rules, like maybe round robin for first request or various other things. And frankly, that just never worked all that well. Trust me, I've had this pain with our own projects over the years, that something just isn't working in that load balancer and suddenly everything falls apart no matter how good your availability plan is. So don't think of it as purely load balancing. There's more to it than that. And now let's talk about how to do availability. And that's where Azure Platform as a Service, or Azure PaaS, really comes to our rescue. I, again, believe it is the best way to do this. And let's talk about how. Let's talk about some benefits first, and then we'll get into the how. I've talked about what not to do so far, and really it's kind of comes down to there's just better ways to do it. There's all these benefits. The fact that when you're talking about platform as a service, your responsibility is more about the code and the application itself than worrying about the underlying infrastructure. Gone are the days of having to worry about what is my maintenance window for updating the operating system. I got to get Windows updates. I got to get patched. Oh, my security team scammed the server and the TLS version isn't up to date. It's not like 1.3 or whatever it is today. So we got to update the registry settings to handle these things. That is one of the huge benefits of having Azure PaaS, is the server is taken care of for you. I mean, yes, behind the scenes there's actually still a server running, but Microsoft's Azure Cloud does that. It's not you. You're not in charge of it. You don't have to think about adding it to the network, what IPs go into it. So really that's where all these kind of benefits really come from, is the fact that you can not worry about that. You can worry about just your code. You can understand where performance is occurring or not occurring. These tools have some ways to help troubleshoot slowness. They have ways to automatically scale out or scale up to add more performance in case things are slow and you're getting a ton of traffic. It's all button clicks or configuration settings if you want to think about it. And really, the huge advantage is that it's super easy to distribute your application in many regions around the globe. And that's when we talk about high availability, typically we need to do that, because what if the data center is a single point of failure? If that thing goes down in Virginia or wherever it is, how would you get it back out to California? And do you have to do that manually? Nowadays you don't have to. And that's where I'm going to show you how to accomplish that with your .NET websites in the rest of this talk. So, and then lastly, of course, there's automation. There's automation for all this. There's automation for how to create these resources. There's automation for how to fall back and fail over in case there's a downtime issue. There's all sorts of automation options. And that's what I really love about Azure, honestly. And it really starts to look like this. So instead of that old server closet that I talked about, it starts to look like shipping containers full of very advanced racks of servers that you don't have to worry about. Because you know what? If one of these things goes down, if somebody has a problem in one of the blades, there's a hardware malfunction in a disk somewhere, the cloud basically can just handle shutting off everything in this little container and moving all the workload to a different container. And these shipping containers are around the globe, as you probably know if you're in the Azure space. And it's just, in my mind, I think of it as a very impressive look to how this is handled worldwide. And I think it's way better than thinking about that old server closet. And maybe that's just my personal opinion a little bit too. So primarily, when we're talking about Azure Platform as a Service, we are talking about Azure App Services. And what I want to dig into is how would we set up and architect high availability for Azure App Services as the primary point of this talk. To do that, it looks like this, okay? Typically, what's going to happen is you would provision an Azure App Service plan in sort of a resource group. And I'm going to skip resource group because I'm assuming that everyone who's listening knows about resource groups. That's just a group of resources for management aspects that you would build. But the Platform as a Service resource type is the service plan. And inside of the App Service plan, you can create multiple app services. And then you can tie those things through configuration to other resources like a database or Azure SQL Server. So this is the starting block, or the starting point. It's our first building block of PaaS, because we will deploy our code to an Azure App Service, hopefully fully automatic through a CI/CD pipeline in GitHub or Azure DevOps or Bitbucket, wherever you're going to do it from. Or if you need to, you can actually publish it right from Visual Studio in a manual way as well. But that's our target environment, is that first blue 4 little square App Service 1. You would take your .NET app or your website, if it's not .NET, and you would deploy it to Azure App Service 1. And App Service 1 is right next to maybe App Service 2, 3, or 4. There can be as many of those as you want, well, up to a certain limit. We'll get into that later. That share resources inside of the plan. The plan is actually what you pay for. It's got a set of performance tiers that have certain costs that go with them. So there's a free plan up to basic, standard, to premium, and there's various flavors of those. And you can kind of pick the right one that's for you based off how much compute power you need, how much RAM you need, how much storage, other capabilities go into some of the planning. But basically, you can start to decide how big your app needs to be through a settings wizard when you're picking pricing tiers. And all of that is the plan. Again, the plan is what matters for it. In a way, it's like your application pool in the cloud is how I like to think of it. And then you can deploy as many apps, just like you could in the old world with IIS. You can deploy as many directories or virtual directories or virtual applications as you want inside of that plan, with all reason in mind. So this is where we start. And again, most databases or most applications do have a database involved with them, especially like the ones that we build at Bizstream, our content management databases with like Kentico Experience or other CMS platforms. This little building block all goes together. And frankly, this may work for your website or your application if it's not high performance or high demand of need. We have some of our customers who just stop here because just being in Azure is a little bit more high availability than being on a server in someone's closet, right? And if something goes wrong, you can actually provision these things into another region fairly easily, but you put it in a region, in a group, you build a plan, you put your code there, and you're off and running. You're not worrying about the server. And these app service plans give you automatic URLs, they give you free SSL certs. There's a whole other set of benefits that I'm not probably going to get into all of that today, but generally, this is the first building block, and it may work for some things. But it doesn't really work for high availability and fault tolerance. So to support that, we need to up the architecture to the next level a little bit. So if we go to the next set of features and functionalities that enable us to have high availability, we'll kind of move our app service plan up a little bit and our database up, and we'll add a couple more components. In my opinion, these are like some of the 4 basic components that you need to start the journey to high availability. The first one is an Azure Redis cache, which handles basically your cache for you, session state, and I'll get to that in a second. External storage account, or blob storage you may call it, with Azure is the next benefit for us that's going to help. Handle file storage as we scale and maybe fail over. Then we get into application insights, which is basically an automatic free service that does telemetry, measuring, and even some monitoring and alerting if you want to hook it up to know how your app is performing on both maybe client-side request time or server-side issue time as well. And then Key Vault for handling some secrets and security aspects of the solution, so that way you're not worrying about connection strings being nested inside of the app code or in your repo, right? Just kind of a best practice. And the reason that we need these couple other components is so that way when we start introducing another set of components where your app is scaling out or scaling to multiple regions or failing over from region 1 to region 2, these are our things that save us for scalability. So if there are files in your website, right, like the static file directory, your logo, your images, maybe some JavaScript files even, or CSS files that you store in your normal Visual Studio project, that gets into the file system of the Azure App Service by default, okay? And because if something goes wrong with the default configuration, that app service may go away and it may spin up a new one, it's not guaranteed to persist exactly, especially if you're making changes to the file system. So one of the first things you need to do is pull the files out of the inside of the service file system and put it into external storage. And there's a very easy set of Nuget packages to do that. There's other configurations for some other settings to help you basically tell your app code that if I ask for something at the file www root path, actually I'm going to redirect that request to look for it in external storage, because that's another resource that can have its own fault tolerance levels, availability levels, replication levels that may still work if the app service goes down or moves. And that's our first thing that protects us for saving those files. So no matter where the code gets spun up, or basically the app code gets spun up, it can still talk to the right set of files. So that's the first thing you need to do to enable scaling, to make sure that there's no dependency on things that are in the file system of the app service. After that, it's session state. And that's where Azure Redis Cache really shines. You know, if you've been a .NET developer for a while, you might think, well, there's normally in-process session state and then SQL Server session state management. So we could choose to do SQL Server session state management, and that actually technically would be fine. However, I'm here to tell you that the Redis Cache resource is a better, simpler, easier, faster way to handle session state. Especially if your application has like a login, like an e-commerce My Account scenario. Session state is really important, that if we ask or make a request from one client browser to one server, or sorry, not server, one app service, that it stays with that the next time it makes the next request and the third request and the fourth request. It should stay in there because it might need to remember things across requests, and it does that basically in RAM or session state. But again, imagine if the app service goes down, that RAM is cleared, and all of a sudden your session is blanked out, and we don't want that in high availability. So we would recommend is using, again, a set of Nuget packages that enable session state through Redis Cache. And that's what the Azure Redis Cache resource is doing in this diagram. And the other benefit is it's super cost effective. It is not a high amount of dollars to have an Azure Redis Cache resource that can handle all this, and it's not a lot of code to do it. So that's why we need those two things. And I'll use a strong need if we're going to do high availability with Azure App Services. And when we talk about the files, I forgot I have a little bit more details here. Here's what it ends up looking like. I've got a storage account here as a screenshot on the left part of the screen, and each folder in your file system kind of becomes a container, or in a way a folder on that storage account, just like if you were in a native file system. And when you click a folder like ACS-demo, you can see that there's a JSON file in there, in the bucks schedule.json. Or other things, images, PDFs, whatever. It can hold those files, and it's this other resource that, again, can have its own sort of high availability components that go with it for redundancy, backups. It just makes it a little bit more hardened against failure, as opposed to keeping it, again, in the Azure App Service. And if you're going to do that, I have a pro tip for everyone. If you don't know about this, please go install it right now if you're in the Azure space. Use Azure Storage Explorer. It's a fantastic tool that from your local workstation, you sign into your Microsoft account, you can browse to your storage accounts, browse right to that same exact container I was showing, and you actually navigate and interact with the files as if they were just almost like an FTP client. And in fact, you can transfer things up and down. And this is good from a troubleshooting perspective as well. You can actually see, if a form on my website has an attachment, like a career form to upload a resume, did that actual resume PDF make it to the storage account? So it's great for troubleshooting. I use it all the time. I can't recommend it highly enough because it's free. It's a free tool from Microsoft. It should be right next to your Visual Studio or VS Code toolbox, basically. So use Azure Storage Explorer. Okay? And when we have those things set up, right, we have the other four components next to the app services. Here's what we can start to do. We can scale scale up or scale out to enable performance modifications. And we can do that manually, as this screen is first showing here. So I'm actually on an Azure App Service. And if I go to scale out on the menu on the left, I can choose to, I need to handle more traffic. I have more load coming to my website. It's running a little slow. I need more resources. I can scale that out, and suddenly Azure will create 2 instances of that app service. And yes, it's going to cost a little bit more, but it basically allows you to have a lot more horsepower with a click of a button. Instead of doing it manually, the next level solution to that is you can actually do it custom, auto scale. And sorry, I apologize, the screenshot must have blanked out there on me. So here's what it's like to scale. You can scale to 2 or 3 or 4, whatever the performance tier that you're in allows you to do. And it's a way to basically add more performance really quickly, as I've been saying. But the other thing is the custom auto scale, the right there in the middle. You can actually have the platform do it for you. So in 2 a.m., you're sleeping at home, all of a sudden the CPU spikes on the app service because you have a ton of traffic that came in from like an email marketing campaign from Europe or something. And you can basically say, if my CPU runs for more than 5 minutes at more than 90%, automatically scale out to do 2 or 3 instances to make sure we can handle that increased traffic. And then over a certain amount of time, you can actually have it scale back if the traffic slows down. So again, that's the benefit of being in a PaaS-based resource. And by the way, you cannot do this with IaaS, right? There's no such thing as automatic scaling in IaaS. I think it's super impressive. We've used it. It helps a ton of clients in the long term. But again, you would need to have your application be set up for scaling before you could leverage this. And that goes back to that second building block diagram that I walked you through. Okay. After scaling out, application insights is the next component that becomes critically important to know what's going on. Basically, it's a free tool. I mean, there could be some cost depending on how many monitoring and alert things you set up, but generally we use the free version. It's a way to know what's working, what isn't in your application. I can't recommend it more. It is a best practice at this point to always use application insights. If you need to do custom telemetry for custom debug or trace, super easy to do. And there's a ton of places around the web that you can see how to add this to your site. It could be as simple as adding a quick JavaScript snippet into a GTM tag, right? But I definitely recommend using application insights anytime you're using anything Azure PaaS. Also, as I said before, the next best practice in doing this with PaaS is Key Vault. Again, the goal here is no secrets going into GitHub. That could potentially be an open source, wide open thing that everyone could see, like your API keys or database connection strings. Use a Key Vault to store those things. Use the right Nuget packages to your code base to be able to pull that from a connection string standpoint. That all just, I always recommend using this because not enough people do it or know about it, and I don't know why, honestly. So if I could do another talk, I would do a whole talk on why Azure Key Vault is so important. But generally, I didn't want to mention anything Azure PaaS without mentioning this. So please go use it in your projects. Okay, so everything I've done so far is all about performance and scalability and setting us up. You know, we've done building block 1 of starting Azure PaaS, building block 2 of enabling scalability, but we haven't got to high availability yet. So let's do that next. And if you think about it, we need to add a door into our solution that handles the incoming traffic, and it kind of is our quarterback, if you will, of where should requests go to when we talk about high availability. Like, what if somebody's making a request and suddenly the server or the app service is broken and not working because maybe there's a problem with Azure? You know, maybe it's an East Coast problem, and what if there's something working on the West Coast? Well, we add a door into the solution on top of our building blocks to make high availability possible. And we do that, funny enough, with Azure Front Door. Azure Front Door is basically a web application gateway or in a way, web application firewall that you add on top of your resource groups to handle that quarterbacking, if you will, or that traffic management, or the directing of requests and understanding are things healthy or not. So you add what's called a backend pool into your Azure Front Door. And the backend pool can be almost any kind of resources you want. And then you configure a front-end domain. So in the example here, I made a quick KX connection demo front-end domain that I would point my public website domain to, or my custom domain to. And then all of the other request would get kind of proxied through this front door resource, and it would handle determining where do I go? Are things working or not? And it starts to look like this. So we've taken, now we're on like, building block 4 here, or 3 or 4, whatever it is. And you start setting up multiple instances of your app in a primary resource group and a secondary or maybe even a tertiary resource group. And they're really kind of replicas of making sure that maybe I provision one of my app project solutions into East US2 region, and maybe I push another one into Central or West. So that way, if there's a problem on the East Coast with the cloud framework or the cloud platform, and suddenly traffic isn't being resolved the right way, I'm going to automatically fail over to my region B, as in this diagram. And front door is the thing that sits on top of that you configure fairly easily, actually. I want to tell you that it's pretty easy to configure this. So say that, I'm going to route all my internet traffic from front door to my primary resource group, which is, again, my normal app service. But if there's a problem, if I can't get a response fast enough, I'm going to fail over to that secondary resource. And it starts to make a lot of sense from if there's problems, but there's also the components of how do I tell front door that there is a problem, right? And what do I need to modify to my application to ensure that all works the right way? And what other things I need to configure? Like actually, when there's 2 databases involved, and you're talking like e-commerce or just big branded website, you got to worry about transactional data. And how do I make sure that if region A fails and goes dark, how does region B's database know and keep up to date? And you still, at the end of the day, you kind of need to use some replication technologies that are part of Azure SQL to do this. Honestly, SQL replication is like not my favorite thing in the world, especially since I started SQL Server work when it was like SQL Server 7.0, and it never worked the way it's advertised. I swear it never worked the way it was advertised. But now with Azure SQL, I feel like they've actually kind of fixed that, and this stuff works pretty well when we set up the read-only replica or other replication styles that can keep 2 databases up to date fairly easily. So this is kind of our target picture for high availability when it comes to Azure App Services. You provision 2 sets of resources into different regions. You're protecting yourselves at a high level, and there's a couple more things you need to do though to your app to make this solution work. So if we kind of zoom in a little bit, the main thing that you need to do is in your application, at the application layer, add something that's called a health check. And this is the smartness that is kind of that 2-way communication between the WAF or the Azure Front Door resource and say your e-commerce website. Because what happens is Azure Front Door asks on a periodic basis, on an automatic recurring kind of quickly every kind of, I don't know if it's every 5 seconds or every minute or whatever, it's very fast. And is that website working? Is it working? Is it working? Is it working? And it's your job as the website developer to add a health check so that Front Door can make a request to like /health check, and your application responds with a 200 to tell Front Door that yes, I'm available, I'm working correctly. And actually you do that in all of your backend pools that you've got set up because it's going to ask you to configure health checks. And that's the smartness. That's how the Front Door, like the traffic manager, can quarterback the traffic between the primary resource group and the failover of the secondary resource group. It does that through that health check communication system. And I thought this was going to be tough to set up. I thought it was going to be really hard. Like, oh, wait, we got to do multiple things to the code base. But honestly, here's where Microsoft has your back. There is a Nuget package that you can add into your .NET application for health checks. And whether you're on .NET Core, .NET 6, .NET Standard, whatever version of .NET you're using, as long as you're using a package like this and you're configuring it to be in your startup of your URL of your like .NET Core app at maybe like /health or /health check, and it responds with a 200 or healthy as we're showing here. And that's what this Nuget package does, by the way. You add the Nuget package and it pretty much does all this for you. There's a piece of documentation you can follow, of course, to actually fully set it up, but it's actually pretty simple. But that adds a health check into your app, and that's what you would use. Okay? So I'm going to go back a second, because to be clear, that's when the health check is there, your apps are running, they're provisioned the right way, you've got front door going, that's pretty much a very good spot for high availability when it comes to Azure App Services. I'm hoping that makes sense. I've talked a ton. I'm going to quick check the chat. Any questions for what's going on? We've got a couple of people watching. So if anybody wants to throw any questions in there, feel free, because after this we're going to move on to some other topics. All right, no questions. That's fine. I must be doing a great job of explaining things. Okay, so health check, Azure App Services is great. Now, I titled this talk PaaS options or Azure PaaS because Azure App Services aren't the only way to deliver high availability. And in fact, it seems like there's a new way that comes up every couple months in different styles of hosting a website in Azure in 2022. So the other three things I want to just kind of bring up, and I'm not going to go into depth as much as I did, is there's something called an app service environment, or an ACE. I'll talk about that in a second. And as well as container apps and Azure Static Web Apps. Container apps obviously are about containerization and Docker and making basically serverless container apps happen. And static web apps are a little bit targeted at Blazor WebAssembly and Jamstack based sites. But I do want to quickly mention these three things because maybe Azure App Services isn't the right exact choice for a simple site or for a more complex site. So there's a couple tools in the Azure PaaS toolbox, if you will. Okay, and App Service Environment, or ACE, is very, very, very similar to an app service and an app service plan. In fact, it's darn near the same thing, but the difference, as you can see, is that it's a fully isolated, dedicated environment. And when you're trying to achieve at an enterprise level, at high scale, for lots of resources, and you have security requirements that you cannot have it on a multi-tenant or public type of setup, as Azure App Services are, that's when you need an app service environment. It kind of gives you this ability to do a full isolated version where you add an app service environment, you provision an Azure virtual network, and all of your stuff is in one secure spot. And in fact, your automatic URL changes to where the DNS can be configured to only allow that thing in. And there's a ton more options around setting up and configuring Azure service environments. But it's not for everyone. But one of the sweet benefits is when I talked previously about like failing over between region 1 and region 2, an app service environment automatically has this failover concept built into it as long as you provision it to more than I think it's got to be 3 instances of the app service. And to do that, you actually can't even do that through the portal. You actually have to use an ARM template, and you configure zones. Right here in the middle of that little JSON configuration in that ARM template is you basically tell the Azure management world that I'm going to provision an app service environment. I want to have it in multiple zones. And as long as you have it, I think, in 2 or 3 zones, if East US goes down, it does everything automatically for you to make sure West US version of your app services work. So this is like the top level of enterprise grade high availability because it kind of handles it for you. The link that I have at the bottom talks about maybe a little bit more about how to explain this because I don't have a whole another hour to go into it, but really app service environments are meant for when you are doing very high scaled things. They said that if you have more than 20-30 different app services, you want to use something like this. If you have very high compliance needs, you need isolation, that's where app service environments come in, right? So it's meant for the big of bigs. It's not meant for just normal mom and pop websites. So that's one option for high availability. It's kind of more built in, it's more automatic, and it has that automatic failover, which I think is cool. Next thing I want to quick mention is Azure Static Web Apps. And Static Web Apps also have some high availability built into them as of very recently. But in case you haven't heard of an Azure Static Web App, it's fully different than the Azure apps that we just talked about. It's a way to host static files that make up websites. So think about your Jamstack-based sites, JavaScript, APIs, and markup, or your SPA templates, like a React project from Create React App or Vue.js or Angular. This is the Microsoft's answer for how to host these things at a much, much less cost than the full-blown Azure App Service. Seriously, the standard version of this starts at, or it's like $9 a month to do the standard version of Azure Static Web Apps versus Azure App Services, which can be hundreds of dollars a month, right? And I've done this in a couple projects. This technology is frankly amazing. Now, what happens is you can connect a GitHub repo that on a pull request or commit to master can automatically deploy your files right to Azure Static Web Apps. It gives you an automatic URL, free SSL. It even gives you a preview environment for your PRs that you can have 2 environments running at the time. And the icing on the cake is it has serverless API layer built right into it. So you can do Azure functions right in that same static client-side project, and you can call something like a headless CMS, like Kentico Content, to get your data to make your static website actually dynamic to your users, but still use a serverless static-based option. So if you need a very fast website that can even be dynamic or static, this is a fantastic way to do it if you don't need like a full .NET full framework. Again, this is mostly client-side technology, Jamstack-based technology. But they recently added the idea of this enterprise-grade edge capability to Azure Static Web Apps. And this, in a way, actually backs your static web app resource with Azure Front Door and Azure CDN, so that way you can distribute your static file on the CDN to the edge across the globe. So it keeps it even faster, and it's really an amazing technology. But there is a little bit more cost when you add this layer. But this will give you a lot more high availability because you know what? You're not even worried about a region at that point. You're distributing it on the CDN, and now you're in multiple places in the globe automatically. And that's a great way to get high availability, right? So also fairly new. It's kind of only out for a couple months. It's probably still in preview. I don't think it's in GA yet. So I don't know if you really want. It's a great way to play around with things, but I don't know if you want to go full production yet. So with that, I've kind of covered some really great options for how to add high availability into your .NET projects with Azure. I didn't get into every single benefit. I mean, Front Door does even more things, like security aspect of denial of service attack protection. It can do load balancing, traffic routing. It's a web app firewall. It can help those health probes with health checks that we talked about. But really, PaaS itself, the fact that it gives you like automatic SSL certs, the scalability, the performance, you don't have to worry about maintenance as much. There's definitely more security. And I didn't even get into one of my favorite parts, the deployment slot feature, to have zero downtime, where you can have a version of your app go to a slot, and with a button click, you can swap out production with that slot, and you can even basically not have to worry about scheduling that downtime window through Azure App Services. So I'm not get into all that because that's more deployment stuff. But yeah, tons of benefits when it comes to Azure PaaS. Of course, there are some cons, right? Nothing's perfect. When we start talking about scaling up and out, and we start using Azure App Service environments, there's a big degree of cost that can come with those things. So make sure you're keeping an eye on costs with your cost management strategy. There definitely is some access restrictions for you can't get to everything. What if you need to have some sort of weird Windows-based component as part of your website? You can't necessarily do that with PaaS. And sometimes just the way things are in maybe a big financial service company or a company that has a huge ERP system that is not available anywhere outside of their network, it's going to be tough. However, there's this idea of hybrid connection manager where you can maybe still do this. But just I've run into a lot of projects where there's a lot of on-premise big type of systems that in no way are they going to open their doors to the cloud. Maybe that's not the great place for Azure PaaS at that moment. And as I said before, dealing with SQL database replication is never fun, no matter where you are, at least in my opinion. And there's some learning curve as well. That's why I'm saying it's not for everyone. But generally, I think the benefits very much outweigh the cons. And that's why I think that when it comes to Azure for high availability, especially Azure PaaS for high availability, it's an amazing way to do it. There's a lot of love that I have for it, as you can tell. And I mean, it's clicks of buttons to make these things happen. You can test them out. You can tear down resources. You can turn them back on. It's just a fantastic way to do it over dealing with physical servers or even virtual machines, in my opinion. So I encourage you to use them in your projects. But with that, I do want to thank you all for listening to the talk today. If you have any questions, definitely feel free to put them in the chat. I'll happily answer them. If you do want to know more about Bizstream or what we do, feel free to check out bizstream.com. Also, you can email me, see me on Twitter, my blog, where I do talk about Azure tips and tricks, as well as Kentco experience and content by Kentco. Feel free to watch that. I do have a podcast as well. You can listen to some of that, get into little Azure things here and there. But really, that's all I had for you today. So, and thank you. I appreciate the comment. I'm glad you found it useful. I do hope you enjoy the rest of the conference. And, if there aren't any other questions, I can give you a couple minutes back in your day. Hey, Dan. Good to see you. Thanks, man. Put that back up, I guess. All right. Well, thanks, everyone. I'm going to end the broadcast. Please do go enjoy the rest of your day.